David's presentation is titled Cloud Gauging and the Future of Railway Data.
Thank you very much. Thanks for the intro, and good evening, everybody. I trust you can see the slides and hear me okay. Wave if you cannot.
Yes, we can see the slides and we can hear you fine, David.
Wonderful, that's great. Okay, well, first of all, yeah, thanks very much to the PWI for the opportunity to present. I got this slot at relatively short notice, so I pulled something together that I hope will be interesting. But let me just jump straight in and just give you a quick idea of what I plan to cover in the next hour or so. So a little bit about myself, although the intro from Greg, I think, covers most of it. A little bit about the history of gauging and how railway data sort of evolved. A little bit about today and how things are at the moment. And then some of the traps that perhaps are easy to fall into as technology has kind of moved on. Easy to fall into, but there's a few ways to kind of try and avoid them and give you a slightly different perspective. And then really onto the future, my vision of what I think what D-Gauge we believe it should be like, or arguably will be like. And then if we're lucky, some time at the end, if I haven't spoken for too long, to perhaps raise some questions and have some discussion. So okay, so one caveat before we start. So I am not a rail engineer. I'm not a track engineer. I'm a software engineer. So this may be a little bit of a departure from previous technical presentations. That might be a good thing. It might be a bad thing. So I'm going to bring it from my perspective, kind of through the lens of technology and data. Plenty of what I share today is obviously grounded in facts and the reality of what's happening. And a few things will be predictions, opinions, as the fun with the future is that we don't quite know what it's going to be, but we can look backwards and make some pretty high confidence predictions. So at the very least, I hope you'll leave having explored a few interesting ideas, whether you agree with them or not, but it's a new perspective of what might be possible. So a little bit about my background. We've already had a short intro, but what do I know about rail? Why should you listen to anything I have to say? Well, I guess a very short history. I started coding in the late 80s, thanks to very early encouragement from my civil engineer father. Did quite a bit of graphic design, started a few businesses and studied artificial intelligence quite a long time ago now. Certainly what would seem like the early days compared to how far it's come. I've worked across quite a range of sectors, spent quite a while at a software house in Solihull, building a range of products in different sectors, from manufacturing, stock control, automotive, and then I specialized, I guess, more into innovation. So prototyping new products and experiences, mostly for engineering. I dabbled a little bit in augmented reality and kind of UX design, which has sort of steered the last few years, and then finally joined D-Gauge in 2019. Since 2019, I've obviously built a team in our Birmingham office, worked on D-Gauge Flow, which is a tool for passenger stepping safety, and D-Gauge Rift, which I suspect a few members of the group probably have heard of or perhaps even users. And I was actually fortunate enough last year to attend one of the PWI TrackWorks sessions, which I have to say was actually a brilliant experience to be involved with. So really, really valuable and helped bring back some of the hands-on practical experience to back into the software, especially within that track design functionality. Most recently, I've been working to grow the product in the UK and most recently internationally. And I would say, yeah, I have a passion for user experience and design and a pretty much disdain for acronyms, which I know I'm in the wrong industry for, but I try my best to simplify things. And to say I'm a futurist, so I try and live a few years ahead of where we're at just to be able to see what's coming. When I'm not working, I riding roller coasters, trying wine and trying to take shots with my telescope. So let's jump in. Let's remind ourselves about how kind of gauging started, or at least digitized gauging. For that, we have to go back in time a little bit. So really, the birth of digital gauging was kind of back in the DOS days, paper-based sort of everything. I guess in some ways, the sort of field of digital gauging was, kind of partly brought about some of the work by DGage's technical director, David Johnson. Early versions of Interactive Track Designer, ITD, which later became ClearRoute 1. And back then, surveying was, I guess, more primitive. The first laser scanners arrived in the early 90s, structured gauging train. Databases weren't really a thing. Everything was file-based. It was about collecting on site and sort of bringing that back to the office. Hardware was expensive, I guess, compared to people. So it was typical that you had several people sharing one piece of hardware. There weren't lots of devices around like there are now. And I guess, yeah, hardware sales were at least as important as software. I guess if we kind of summarize it, it was the first part of digitization, but still the whole process, if you look at kind of gauging as a discipline, was still quite manual, a little disconnected. There was quite a bit of double entry and sort of long waits between steps. That's probably the way that I would categorize that. If we sort of try and pull that into sort of a workflow, if we visualize it, I guess it'd be something like this. So we have sort of file-based inputs. So survey data as SE0s, you've got vehicle models as vehicle files. There's quite a bit of manual config and input. Even if you fired up a piece of software like ClearRoute, there's probably a lot of checkboxes and a lot of config to get it to work how you want. Applying your track design potentially, and then running things. The gauging tool itself was really only one part of the process. It was really a calculator. There was an awful lot of manual steps beforehand, a lot of manual steps afterwards. So even when you got your results, raw clearance data would kind of come out probably in a text file, and the next step would be to print that out physically and on a plotter and stick it in the post, or maybe even deliver it round. We're talking before email potentially. And archive was stick it in a filing cabinet. That's realistically the flow. So I guess the innovative part, the smartest data bit, was probably somewhere around here. But that's roughly how things flowed. If we zoom out a bit further from that, then, so that's kind of really within the office. So yeah, if we zoom out beyond an office and kind of look at the bigger picture, as it were, it's one way to categorize this would be several distributed offices, each with their own local storage of data or files. You'd have your laptop or PC with software on, and plenty of trips to on-site. You could go on-site and collect information. You'd bring it back and probably type it in again, or sort of download it with probably a USB cable or a serial port or whatever it was back then. But yeah, communication between offices was largely pretty manual. You pick up your phone, or you go and visit someone, or perhaps even send them a fax. So why is this important? Well, I guess if you zoom out, you can see that there were very few shared resources. Everything was quite localized. So there was intelligence and innovation on a particular device, but there wasn't really this kind of joined up picture. It was kind of relied on the efforts and the intelligence of individuals to sort of connect the dots. That's really what the model was like when things started. Let's fast forward then, I guess, sort of 25 years or so. Track design office probably looks a little bit different, probably something kind of more like this, bigger screens and more people with higher resolutions and stuff, but ultimately it's the same elements. You've got surveying, you've got asset management, you've got CAD design, and you've got gauging assessment. So I guess surveys are far smarter now. You've got handheld devices, potentially with data connections. After collecting so much data manually, there started to be centralized assets. So things like the NGD, things like INIM, and I guess back in the day was GIS or GeoGIS. So those assets have started to grow. So asset information team, the sectional appendix, these are all centralized data resources that are helpful for multiple companies and multiple offices. They're mostly distributed digitally. Gone are the days when we're posting around CDs and things like that. So we're definitely moving forwards. CAD has moved really from Draftsman to early versions of AutoCAD to something far more powerful and centralized. I wouldn't say in the cloud, but certainly cloud subscription. So just like Adobe's kind of software as a service, you have the ability to be able to pay for software and keep your files in the cloud and be able to run it on any machine that's sufficiently powerful. Software, I mean, we're gauging software again. You know, we're in the cloud with dgauge Rift, which makes leveraging the power of cloud computing. It's less important about the hardware you have physically in your office. Better storage. There's still the need to be able to download files for reports. But we're starting to see some parts of the process becoming more centralized and more abstracted away from the office. If I was to, and then finally, work habits certainly have made, certainly the last few years have changed, especially with COVID, working from home or not being in the office. Remote connections to things have certainly been something that's had to take place. Some organizations have relished that, others have struggled, and it's probably the legacy tools that have been stretched the most in that change. And if I was to categorize that sort of flow of things, I would say it's probably patchy. There's brilliant bits in our workflow. There's really good innovation. There's some great new tools. There's some really good data sets, but there's still some legacy parts in there too. So it's sort of depending on which part of the process you're working on, it may be frustrating or it may start to look a bit joined up. If we go back to our data workflow, what does that really look like? What does gauging look like as a flow now through the lens of today's technology? Well, we still have our input data, but rather than it being file-based, things have moved more to the internet or to databases. So our CD or floppy drive full of SE0 files is now a data set, the NGD, that you can download, or even comes out of the box. Engaging software, vehicle libraries, vehicle files have become libraries that are just available in software tools, automatically updated. We've got a process for updating the NGD. We've got the new RGDS contract that provides surveys more frequently, hopefully at higher quality, and even more accessible. And I think a lot of the manual config, a lot of the learning curve that existed a few decades ago has sort of been shallowed. So rather than only trusting your most experienced, your most diligent and meticulous users, software is becoming much more approachable. So the ability to just get started and follow a template rather than remembering which out of 60 checkboxes you need to click sort of softened a little bit. CAD software is still there. As I said, the way to access that is probably through software as a service, so more of a subscription model and licensing. You don't have the sort of the CAD workstation in the corner. It's something that could be run on hopefully on any half-decent machine. Gauging calculation still takes place. But rather than submitting raw data, we're able in tools to be able to generate customer-facing reports. So PDFs and Excels and plots and things, much more forthcoming. Now, we're not submitting those digitally. We're still downloading them and emailing them to our end user, which is, I guess, a little bit 1990s, but still we're getting there. But at least archiving of data is no longer, hopefully, reams and reams of paper in the corner of the room. It's more we have cloud storage, which is great. So the scope of software is expanding. We're starting to join things up more. It's less individual files and it's more solutions. Okay, so let's zoom out again to our big picture. How has the world changed? If I was to categorize how these different organizations and systems interact, I'd probably draw something like this. So we still have our office, but we've got more people working remotely. You've still got local data in these offices. You've still got the server under the stairs or the IT room or something in most buildings. You probably don't have that at home, but you have got devices where you need to connect. So you might VPN into your office. Equally, as well as going on site and having smarter tools there, we've got this idea of cloud services. So very few people will be hosting their own email, hosting their own gauging servers, hosting their own survey libraries. These are things that are available now in the cloud, which have their own storage. So one way to think of it is a little more of like a hybrid system. So you've got a mixture of data in different locations. Some things are a little more legacy and local. Some things are a little newer and therefore accessible out and about. Hence the propensity for mobile devices, connected smart devices for surveying and even engineering work on site that can, assuming there's a data connection, can talk and download information and upload surveys directly. Gone are the days where you're scribbling down on a piece of paper and driving back to the office to type it into a computer. So yeah, multiple shared resources. Collaboration, you can still talk to people directly, but then there's the idea that even tools like Teams that we're on now enabled because of the cloud, allows multiple companies all around the country, if not the world, to be able to talk together. Okay, so things are starting to get a bit complicated now, actually. The diagram seems a bit messier than it was before. It's nice to have some things in the cloud, but it's really easy when you're partway through a transition from one methodology to another, things that usually get maximally complicated. And you could be forgiven for saying, well, actually, things were much simpler in the old days. Why can't I just post this thing out? Or why can't we have just data in one place? Why do I have to log into these 15 different systems? There's a few traps that can well, trip you up into if you're not careful. And it's easy to make decisions that feel like a step forward, but in fact, potentially could be a step backwards today compared to a few years ago. And I've just got a few examples of those. So I just picked just a handful of examples that things that may have been true a few years ago, but could be more of a hindrance than accelerated today. So I'll just zip through these and, just a smile if you've heard one of these sentences before. So the first fallacy is we need to buy a data set. The number of times I've spoken to companies who have bought a database and only then do they think about what they might actually want to do with it. Ultimately, it feels like an asset, it feels like something worth having, and it's an enabler. What I would say is data is useless without the tools to process and turn it into information. So what you should really be thinking about is buying solutions that leverage data. Data alone isn't the most valuable thing. In fact, in many industries, data is actually cheaper and much more widely open and available than you realize. Most people could download and have access to these data sets, but they don't have the tools to read and manipulate and benefit from them. The moment you download a set of data, really it's out of date. So I would say at least as much priority should be put on maintaining data and keeping it relevant as to commissioning the data set in the first place. So the lesson here is really buy data solutions, not data sets. So fallacy number 2, our solution should be in-house, otherwise we've got no control over them. Now it depends whether you're an infrastructure organization or a design house or an international, I guess the requirements come at different levels, but everybody's worked in a company where there's that one smart person who offers to build a super spreadsheet in a couple of weeks that everyone can use. And as long as they don't get hit by a bus or leave the company, the whole business is relying on these few files. We've all been there. Now, it's a noble offer, and it's the kind of trap that a lot of people fall into. And most companies do have that person, or if they're very lucky, a couple of them. But what every company doesn't have is someone who can spend 50% of their time maintaining and updating that tool, manning a support desk, maintaining compatibility with the endless advances in servers and databases and components and cybersecurity compliance and GDPR to keep a tool like that relevant. So it starts off in a good place. However, internal tools started with the best of intentions can silently mature into time bombs of legacy maintenance and interoperability. And you dread the day where the person who wrote this thing leaves and we've no idea how to do things. So sometimes those tools can ironically become the hardest to integrate with off-the-shelf tools when they become available. It's the bespoke things you have that potentially hold you back. So the advice here is prototype internally, evolve your process, but don't build your whole business around it. Use that learning to form a specification for a proper tool that you know will be fit for purpose. Better still, encourage your peers and colleagues and partners to be able to fund it too. That way it will secure the long-term future of that tool. Take an idea and bring it into the industry, and it's something that will last and will naturally have a team of people working on. Fallacy number 3. There's no point in tackling only part of the picture. If we're going to do this, let's look at all of it. Now, I've worked in the public sector in IT procurement, and I learned lots of things there, and some things I wish I hadn't have learned. There's horror stories of Project Titan, Project Everything that promises that will solve every problem. The budget spirals, you're 3 years into the project and you're already 5 years late. And suddenly people start wishing the old system was back, even though it was simple, at least it was, affordable and something you could manage. Some users don't end up seeing the system until it's already been purchased and configured, by which time there's no budget left to optimize it, and all the emphasis has been put on procurement rather than maintenance. So over-ambition and poor user buy-in are the death of so many large IT projects. It is very rarely technology that holds back a system. It is the specification and implementation. So my advice is to start simple. The whole big picture, much as I've tried to draw these things, doesn't usually reveal itself until you've removed some of the low-hanging fruit, until you're well into a project and you're few iterations in. So tackle a small definable problem that you know that will benefit your business and you know that potentially will benefit others. From there, you can grow. The advantage of that is you'll get good PR, you'll get budgets for the next thing because your project was delivered on time because it was a realistic size. And from then, you'll work out where the next avenue is. At the start of it, what you thought where the value was rarely ends up being where the big picture ends up being. So I would say try and be bite-sized and get some traction. Okay, second to last one, functionality is king. So I've had lots of previous directors who would say, I've worked on factories and stock control and MRP, ARP systems, and they look like they're fresh out of the 90s. You click on something, you wait 30 seconds for the screen to change, but it doesn't matter. Functionality is king. It doesn't matter how it looks. Well, unfortunately, the fallacy is that people don't care and that business software is different to consumer software. Well, your next cohort of employees are the smartphone generation. Their expectation for user experience has been set sky high by Silicon Valley. They have no patience to wrestle confusing UIs. They've never read a training manual in their entire life, and they see no reason why the same experience but ordering on Amazon or booking a taxi shouldn't be the same for the tool I have to use 4 hours a day. I've seen tools that do exactly what the requirement said, hundreds of thousands of pounds, fail simply because users ignored using it because they don't like the interface, because it's a pain to use and the path of least resistance is something other than the thing that has been funded and their manager has asked for. Engineering is a complex business, but tools that do engineering shouldn't need to be cryptic. Okay, last one. Could software replace me? The existential threat. Now, software saves me time. That's great if it's intelligent, but we don't want it to be too smart. Otherwise, I'll be out of a job. It's a forgivable concern, but extremely unlikely in a high-skilled engineering sector. Almost every user I've ever spoken to and colleague is stacked full of work, desperately trying to get rid of all the admin and distractions on their plate to get back to what they deem to be their real job, the value add. I've never met anyone who automating a few steps would mean they'd have nothing to do during the week. Several companies differ, but you can reassure yourselves, probably none of you in the room are in that situation. The goal of software is, like cloud gauging software and CAD solutions, is to give the user superpowers, is to elevate their skills and abilities, to get rid of the mundane, to automate the monotonous steps, and to leave them to make clear engineering decisions using data presented in an insightful and unfussy way. Wood for the trees. I'm a strong believer in what you need and nothing else. So software should elevate you. What you'll find is, and there's, a limited number of case studies to prove this, as soon as you add a tool that automates the mundane, you can speed up the bread and butter, and it accelerates a company to help them to explore more challenging work and find new opportunities and scale productivity, but without having to add more cost and more risk and adding massive headcount. So it's about getting more from what you have. Tools should not hold you back. Tools should elevate you. And that doesn't mean there's any risk of them replacing you. Some industries vary. I'm not going to talk about Ubers and things like that, but certainly in high-scale engineering, there's very little risk in that happening. In fact, it's pretty exciting. So there we go. There's the 5. So the antidote for those: don't buy data sets, buy data solutions. Don't try and build things in-house. At least they won't scale. Start in-house and then try and get them out into the industry. That will secure their future. Start small, don't get too ambitious, and make sure you get buy-in from your users. Number 4 is how a tool is to use is at least as important as how many things it does. Some of your favorite tools probably won't do that much, but they'll do it in such a beautiful way you couldn't live without it. And then finally, embrace technology. It's here to help you, not threaten you. So there we go. Those are the five fallacies. Now let's just turn our eye towards outside of the rail industry. The rail industry, after all, is a little bit of a bubble. I've had the pleasure of working across a wide range of industries. I've only been in the rail sector for the last 4 or 5 years. And the beauty of working in the software team is that software is needed in every industry. So when I talk to my ex-colleagues who are working in different sectors, I can learn so much about technology and how it's been applied to transform a lot of industries. So this might be accused of stating the obvious, but just a few reminders really when it comes to technology, which is no project in this world, really no major project can take place without a software or data component. Gone are the days where you can do something without IT being involved. That's just life. Other thing to consider, the most valuable companies in the world, or at least 90% of them, are all tech companies. They're all working with software, they're all working with data, so there's got to be something in that. And as I said before, the next generation of users, your next employees, are all IT literate. They all have the opportunity to pick whatever industry they'd like to join. They're not afraid to move. There's very little friction in doing that. It's super important that rail engineering has the ability to attract future talent and keep it. And part of that is to be able to provide experiences and jobs and workflows and tools that are pleasant to work with. If you're staring at a horrid piece of software, clicking through things all day, every day, it's not something that's very appealing compared to other sectors. Some industries are moving forward better than other ones. I would say in terms of the progressive category, you've got automotive, you've got retail and media, who are obviously cutting edge, and tech is very close to those. Ones that were historically a little backward, but are going through massive transformation at the moment, I would say would be healthcare, finance and banking, and energy. And probably on the more conservative side of things, UK manufacturing, probably construction, and certainly legal. So these are industries that are potentially ripe for major transformation by technology. So yeah, getting young, good talent is a virtuous cycle, but conversely, not having innovation is a vicious one. You find that you don't have good tools, which means you don't get good people, and then the whole cycle continues. Moving on more to major tech trends. I mean, there's an awful lot to talk through, and again, I've only got a few minutes, so I'll try and cover them as clearly and as concisely as I can. There's just 6 or so points. These are just things to keep in mind about what's really happened. What's really happened over the last decade or two. I mean, agile is a word that's misunderstood and overused and bandied around when it shouldn't be. But what I mean here is, when people try to develop software in an agile way, in a flexible way, it was always delivered under the banner of a big waterfall project. So if the specification is enormous and the delivery plan is enormous, it doesn't matter how flexible you want to be in development, you've still got to deliver all these things over a multi-year period. Now, there's a new kind of software development relative to the last decade or so called continuous delivery, and it's a way of developing and releasing software rapidly and frequently. It was required for mobile updates. That's why you don't see Sage 2020, Office 2021. No one is releasing software in a massive lump once a year. The ability to be able to update regularly and silently is how things are working. That's how mobile apps work. That's how your browser works. That's how your operating system works. And it should be the same for CAD software or gauging clearance software. But the other piece of this is procurement. Now, even if you can develop and deliver in a bite-sized way, if your giant contract is a 2-year thing where you must list every single thing that will be delivered precisely right at the start of the project, there's no way to be flexible. And by the way, at the start of the project, you won't have any idea what this thing is. That's fallacy number 2, or what was it, 3? It's the big, don't try and do everything in one go. Start small and grow from there. So you need a commercial model that allows you to be able to start and grow. And that's why large-scale software procurement has moved to more subscription model to service model. So it means that tying in for a few months or a quarter of a year means that you can grow. Okay, so that's really the impact. Yeah, so if procurement works and contracts work, then software delivery and development can work and be flexible. Probably the next big thing is, I guess, cloud computing, big data, and business intelligence. I don't like acronyms, but the BI is a pretty big deal. You look on TV and almost every fourth advert is something to do with Cognizant or some smart business thing, and don't get left behind. There's definitely a FOMO element to their marketing. What does all this mean? Well, really, we've now got to the point where cloud computing and storage is now effectively unlimited. I mean, for a cost. You can put anything you want all in one place, which allows centralization and querying across data sets that you couldn't do before. Remember back the original model where there was data sets locally. One company had one bunch of files, one company had another bunch of files. The idea of bringing those things together and comparing them was a very time-consuming, expensive task. Now you can essentially plug together some databases and a bunch of tools, do some magic, and then start giving you can just query different dimensions and you start to get insights that you couldn't have done before, certainly manually with a human. That tied in with the fact that it can even find things that you hadn't even thought were correlations, or you can test hypotheses. It can find opportunities for business that didn't exist before. This is having a massive transformative effect generally across the business sector across the world, and the same challenges apply really in rail, especially with opportunities for cost saving and carbon reduction. Post-COVID generation, we've talked about this before, but that's certainly having an impact across the world. Remote working, flexibility in terms of location independence and devices. Tools are changing because of that. It's a sort of fickle workforce that are tempted by different industries and low friction for change. The ability to be able to work across any city or country and industry is sort of starting to be expected, and with that comes a different style of tool. Tech industry. So, I mean, historically, we all remember the tech industry we associate it with building and selling PCs, maybe smartphones and search engines. I mean, tech has long since grown past these humble roots. Silicon Valley is systematically, I would say, applying its innovation template to media, healthcare, banking, collaboration and productivity, automotive. There's no reason to assume that they'll stop there. Almost every industry is ripe for reform. So seeing for better for worse the monster grow is something that we should be aware of outside of rail, and there's massive opportunities to benefit from it. AI. So I could talk for an hour easily on this topic alone, so instead I'll keep it very, very simple. AI has been used historically for quite specialist applications over the last 2 decades. Image recognition, expert systems, text-to-speech, that kind of thing. But it's really in the last 2 or 3 years that we've seen a profound acceleration for generative AI. Things you've probably heard of ChatGPT. This is where AI can be used to create content where the rules for creating that content cannot easily be defined. That's what makes the difference. Any piece of software could follow a set of instructions since the 70s, but it's the ability to create something where you couldn't tell it the rules that really is it's brand new and actually pretty exciting. So why does that really matter? It may seem a little bit abstract. How does a tool like ChatGPT that you can ask questions have anything to do with an industry? Well, ChatGPT and generative AI is about mastering language. Now, language is widely believed to be the foundation of meaning and understanding. So by mastering language, you have the ability to build tools that at least appear to understand and have much more meaning and context than before. So they're able to solve high-level problems where rather than telling it all the rules and just letting it to go, it can interpret data sets that aren't even exactly compatible, and it can provide insights similar to business information. It can provide summaries, and it can spot things that normally you'd need another human being to be able to double check. So potentially massively transformative in the next few years. It's hard to predict where it will go, but it will definitely touch transport sector, including rail. Finally, the last one I want to share, Industry 4.0. Now, this is a bit of a buzzword. It's been around for a decade or so. I'm not sure if anyone in the room has heard about it, but it's basically a collection of technologies which are broadly seen to be something that would bring around the fourth industrial revolution. So I've got a slide on that just to explain in a bit more detail for those of you who haven't heard about it. We all know and love the original industrial revolution. Why not? Because it was, amongst other things, it was about trains. The main innovation that led to this transformation of the world, this big acceleration in engineering, was steam. You fast forward a century or so later, the second industrial revolution, if there was such thing, really came about by the innovation of electricity and the production line in factories. So that allowed to be able to scale manufacturing to a massive degree. And there's a bit of a lull, let's say, until roughly the 1970s. If there was a third industrial revolution, it was the invention of the microchip. So we're moving from mechanical ways of engineering into electrical and computer-based ways. So obviously the foundation of this since the 70s really dictated what the world is today. We live in a digital computer, internet-based world because of the invention of the microchip. So the obvious question is, what does the fourth industrial revolution look like? What would that take? When would that come, and what technologies? What is the big transformer that would make this big shift happen? And the answer to that is really this collection of technologies that have been pulled together that are deemed to be Industry 4. And largely the innovations that will make this happen is the internet and artificial intelligence. So there's about 9 different technologies here, 9 things that collectively, as the world does more and more of, we'll see a big change. It's really hard to see when you're in the middle of it, because you've kind of got your head down and it doesn't feel like it's changing quickly. But when you look back, you go, wow, 5 years ago we had none of that, and now everybody does this all day. So these are the things we're looking out for, and some of the things as a futurist I love to think about and speculate. So here's the list. I mean, really the important question is, what have these got to do with rail? I mean, just to be able to go through them one by one, they're actually a pretty good fit, I would say. Simulation, I mean, gauging software is simulation. Ultimately, you're modeling the behavior of a vehicle on a piece of infrastructure. CAD is very, very similar. Ultimately, you've got a digital model of something. So we're right in the right industry here. Systems integration, what do we mean by that? Well, I guess it's the idea of multiple tools connecting and working together. The old paradigm, big picture, was separate data in separate offices. Now moving towards this centralized, more cloud-based thing where every data set can plug into any other data set if the right APIs are provided. Internet of Things is just a posh way of saying every device is communicable. You can talk to it, you can address it, and you can send messages to it. You don't have to use an interface on the device itself. So we're talking about sensors, smart equipment, smart scanners, real-time operations. So rather than having to survey things and collect stuff by human, there's no reason why data isn't just being fed in real time 24/7 from some of these systems. And with that, you can build up a live model of how something works, which feeds obviously into simulation. Cybersecurity goes without saying. If you've got all these tools in the cloud and everything's connecting to everything, you've got to make sure you give the right ones to the right people. Otherwise, it'd be a complete nightmare commercially and security-wise. So cloud computing, we've talked through. And clearly the future of CAD engaging software is with the cloud, where there's infinite scalability. Additive manufacturing is just another way of saying 3D printing. I'm not sure exactly how 3D printing is related to gauging, so I'm going to skip that one. But if you can think of it, there's probably a few applications on site where putting a part together quickly might be helpful rather than waiting to get something CNC perhaps. But that's certainly transformative when it comes to other kinds of manufacturing. Perhaps in vehicle design would be very helpful. Augmented reality is just a way of being able to see data visually rather than on a screen, to be able to essentially put on a headset and walk through it in 3D. Big data we've talked about. And then finally, autonomous device and robotics. I guess you can have a survey system that scampers around the network, looking at the real-time tables, get in the way of nothing. You wouldn't have to go out and do that. How safe that would be, how long away that is up for debate, but certainly autonomous things are on the horizon. So there we go. So that's outside the rail industry. The last part I really want to do is say, if we pull all that together, what can we now say about the rail industry or make predictions about the future of rail based upon the history today and what's going on outside? And essentially, I think they fall into three categories. So with these, with relatively high confidence, we can definitely say these things are coming. The only question really is a matter of when and in what order. So things we can say with relative confidence: devices, software, data sets will continue to transition into the cloud. It's the obvious place to be able to store things. They're accessible, they're scalable, they're secure. And with the different ways people are working, whether remotely or on site or in offices, you can always get to what you need. You don't have to drive to a place to be able to find a database under a staircase. And that will continue to grow. You'll see virtually every new product and offering was most likely to be web-based or cloud-based or mobile-based, simply leveraging that, which means internet connections are essential. But broadly speaking, that's getting better and better, especially with satellite connectivity. The next collection of changes, I would say, would be open and easy integration between tools and data sets. So the idea of logging into a website, downloading some data to your desktop, logging into another website and uploading it again, submitting it, is kind of a laughable process, but it happens all the time. I know, because I have to do it several times a day. Integration between tools will become commonplace, more so than it is. APIs and cloud services make this more and more possible, and more flexible subscriptions and licensing means that you'll be able to connect these things together. It won't be a commercial nightmare. It'll be a plug and play way of working, or at least that's the trend. With that in mind, you potentially got hundreds, thousands worth of sensors and partners all collecting data, all piling into this sort of big data set in the cloud that's accessible, and you can pick and choose. You can license only the parts that you need. You don't have the full picture, but if you're interested in surveying, then that's the data you can get and the tools you can access. If you're interested in engaging or route planning or vehicle design, you can focus on the data sets that are related to your business and your projects. And then finally, the sort of third set of innovations really tie into how users interact with this information. What's possible now we have all these things? Well, once everything's in one place, once everything's accessible online, suddenly workflows on projects become automated. Rather than having to do one bit digitally, then pick up the phone and ask for something else, then post something over and then submit it to another system and all spreadsheets locally. When these things connect together, the workflow, the prompts can be automated. The idea of downloading a PDF and emailing it, submitting it to Network Rail, let's say, is ridiculous. You should click a button which is submit to next party in the process, and the status of that project progresses, and then you get a notification to say it's been approved centrally and you've got clearance to be able to go on site, and then you request your track access and that gets approved. All this information can flow through one view. It's not 15 different documents. It should all be visible essentially in one tool, one screen. Design, there's massive opportunity to move forward. The ability to be able to not manually iterate designs, but for tools to be able to help you goal seek iteration of design. You simply enter the constraints of what you're looking for, and a software tool, whether it be CAD or gauging, will be able to iterate and get to a conclusion. It's not going to be able to make every decision for you, but you could go, I had a go, this would work, or you've got 50 mil, a tamper would work, or try in this direction, or I've already explored moving it this way, that's out of the question. So it can help explore avenues even before you've asked for them, because it's got enough context to be able to explore. Route finding, route opportunity, the idea that software could essentially be a sat nav, especially for freight, huge opportunity in the industry. The idea that you've got an out of gauge load and it can simply go, well, this shape, I've tried all these avenues and here is a way that would work and here's how long it would take. Opening up new markets and new projects that would typically take a really long time could be a few clicks or something. You wake up in the morning and the software's already had a go for you. There's a whole bunch more, but we're probably running out of time, so I won't go into too much more detail. Smart plant equipment, smart tampers, it downloads the design online. You don't have to type everything in. The as-built survey is collected at the same time. You're essentially downloading and updating this one digital model. There's not separate, distinct data sets that you have to join together. It's all connected. And then finally, reporting tools that tell you where you are adding the most value, the projects that are making you the most money, the opportunities that are coming your way, or projects that could be bind together or in the same location. So it's just big picture stuff. Finally, back to our diagram. We had the hybrid model, which looked a little bit messy. If we catapult ourselves into this future kind of vision, how do things look? Is it even more messy? Actually, if anything, it sort of gets a little bit more elegant. As soon as you have let go of local office-based or desktop-based tools and data sets, and everything is shared in the cloud, you get this centralized ecosystem where it can be accessible anywhere, whether you're on site or at home or on a plane or an airport or at home. There's a whole bunch of tools. They talk together best as they can. Over time, they will migrate more and more to the cloud. There's no impact on productivity based upon location. And the compute power and the scalability is essentially infinite. You can keep going in the cloud. You can store whatever you want. And this is accessible internationally. Because everything's centralized, AI has the opportunity to provide insights and suggestions for work. Because everything's in one place, you've got the full picture, more than a single human being could possibly fit in their head. Now, this big picture might seem a little bit unrealistic. It might seem a little bit kind of head in the cloud, to coin a phrase. It might seem like decades and decades, if ever, that it will happen. The idea that so many different companies and suppliers would all work together and there'll be one platform where you could access everything without having to buy separate subscriptions and log into different things. All I would say is that it may seem fanciful, but there's already a really good model for that happening that's been made possible by cloud solutions. 20 or 30 different tools and different companies you'd have to go to have all been centralized into a single platform, and most of us will have one in our pocket. The smartphone is the perfect example of centralization of cloud services that talk together. You can pay for individually multiple different data sets, but they're accessible in one place in a really, really simple and easy to use interface. So there is precedent for this in tech. It's just simply applying the same methodology, but in the context of RHEL. And I think that is the direction that cloud computing and gauging software will go in. So in conclusion, the railways were around for the first industrial revolution. We have the opportunity to be relevant when it comes to the fourth. There are some legacy behaviors and systems to let go of, ideally as quickly as feasible. And the move from a hybrid system where things are partly digitized, partly in the cloud, will give way to a much more elegant solution where things are more centralized and the real benefit in connecting systems together becomes possible. The beautiful thing about the future is it's not written yet, so we have the opportunity to shape it, and we can shape it by the investments and project decisions we make in the coming weeks and months. So that is it. Thank you much for listening. I think that was about 45 minutes. I haven't done a full run through for, so I'm pleased it wasn't 2 hours. I know I've covered an awful lot. I apologize if I spoke too fast. Otherwise, I'll open up the floor for questions.
Very much, David. That was excellent. I've got quite a few comments myself, but I think I'll keep them for when I give you the vote of thanks. So I'll just field some of the questions and comments in the chat, if that's okay. And scroll up. Yeah. I actually thought Tom was ordering an Uber or doing some technology in his phone, but he was actually writing some comments and questions. We'll run through the first one.
Ask the ones that people are frightened to ask, right?
Great.
Please.
Yeah, no, we'll go for it. So Tom's saying there, as software has advanced forward, the user profile has moved backwards. The issue here is that younger, less experienced users generate data and may lack the experience to sense check the output Is there a need for basic clearance analysis training to be provided, and would DGage be interested in promoting such? I'll pause there and let you consider that before we move on.
Yeah, that's a good question. I think the point there is just because software looks easy to use doesn't mean the risks of partly understanding it or using it the wrong way aren't elevated. I think certainly from the innovation and future side of things, the idea that kind of AI can help guide you and steer you to correcting contextual mistakes is potential, but I think that's some way off. I think I'm a firm believer in basics, the first principles and foundation for something. And at DGage we do run gauging kind of one-on-one courses that get the basics across. I think all of this automation and simplicity comes on a firm foundation. So I'm a massive believer in investment in graduates and new users. I would love for everyone to be using our software who's a brand new user who's never used clearance software before. But I think it's key to it. Training can be delivered in lots of different ways, but ultimately it has to start with the basics.
I was perhaps trying not to be maybe a bit unfair, Dave, that what we're saying is in the industry where we've got lots of new intake, lots of new users, and it's getting them to understand what that data means. What does a foul actually mean on the dark and the worst and the most conservative? What do they have to do with it? What does it look like? And I think it maybe it's not a problem that DGage can solve, but maybe DGage can contribute to the solving of by inventing some kind of gauging training for the novice. That's where I was trying to aim that.
Yeah, that's fair. And I think visualizing things. So one of the things that I picked up on the TrackWorks program I did was it's very different to seeing a diagram or a scribble on a whiteboard, even from an experienced engineer. But when you are there looking physically at the object, suddenly a lot of context becomes clear. So I would love to see training to be more visual, and there's a lot of technology that can help that possible without necessarily having to get track access, and you can have larger numbers of people doing it. So there's certainly an avenue there.
But there's maybe an opportunity there for the PWI and DGage and the like to get involved with perhaps a heritage railway that has a platform or structure where you can actually have some practical gauging track work course to help those analyze gauging, to let them see what it means.
Sounds great.
Yeah, excellent. Yeah, so another observation from Tom there is sharing truths and predictions is essential moving forward. It's easy for those without practical experience to be convinced by statistics and science, but it's important not to lose sight of the practical aspects of gauging. Foul isn't unless all the conservative considerations line up. Kind of what we've covered there, yeah. Mm-hmm.
It's just that when people see foul, they go, "Oh my God, the train's going to hit the platform." Yeah, when the time sat in the rain with the worst wheels and the worst side wear and the worst cant, all of that stuff's got to line up. So when that stuff lines up, yes, it is foul. Other than that, you can stick your fist between the train and the platform.
Yep, absolutely. And that's, I guess, where, kind of more probabilistic methods kind of give a closer approximation to the reality if you were on site.
Yeah. So are we getting to the stage where probabilistic methodology would be the future rather than conservative methodology?
So I didn't put it in today's presentation. Again, I could talk for a long time probabilistic. I suspect that will probably be a topic of an upcoming PWI presentation from DGage. So the methodology is there. It's a matter of just simply finding the right projects to apply it and kind of get the industry-wide kind of adoption. So there's plenty of opportunity for it, but I would let one of my colleagues who helped define it present the next steps for how to deploy it. But certainly through the technology we have, because probabilistic is so complex, it's order of magnitude more compute intensive compared to absolute gauging. It's only with technology like cloud computing that that scale assessment is possible, which it now is.
I don't know why camera isn't picking you up, Tom. Whenever you speak, it's supposed to follow you. But anyway, hopefully it'll go soon.
It picks up Jack instead. I'm a film star anyway. Obviously.
Okay, so some more observations there. Making sense of data analysis is vital to understanding if there is a problem or not.
That was just reinforcing something you said, Dave, that we can produce the facts and figures we want, but the human at the end of the day has got to understand, is it a problem or is it not? I guess essentially that devolves all the way down to the gauging engineers, those that sign it off as safe and fit to run that particular type of train.
Yeah, and it's about context, isn't it? If you look at raw data, it can be open to interpretation, especially for someone who's less experienced. It's knowing all the context that leads into that and turning data into information. And it's like, what does this really mean? What decision do I have to make? Sending someone a blank spreadsheet of a bunch of numbers, you can glaze over, but it's what we try and do is provide information that helps inform a clear decision.
Worse than that, when you send a spreadsheet with color-coded cells that tell you've got lots of red flags and you shouldn't be running trains at all, and actually that's not, it's turning data into information, I think is the key thing you said. It's making the human brain analyze that and understand, what does it mean for a train service?
Absolutely.
The next one here is something I'll mention briefly as well later on. Good to hear your opinion that AI won't replace track engineering anytime soon. It'll probably replace hundreds of civil engineers, but it can't replace track engineers. How do you see identification and development of the opportunities that tools which ease the burden of analysis being used to our advantage in the future?
So, yeah, burden of analysis. So I guess, yeah, this is still on the same topic of making sense of data. You can run a big assessment, you can export a bunch of things out, but what does that really mean? I mean, we do a fair amount of what we call gauging commentary work, which is really trying to summarize these things. You know, the assessment is one part of it, but really the recommendation or the final report is sort of where the most valuable human piece still exists. I think in the shorter term, the priority is really to free a user up to do those things. If someone is there copying and pasting cells into a template or PDF or chasing emails and ringing people or trying to download things, they're not making the kind of valuable engineering decisions that they were hired to do and what they enjoy doing. So just freeing away the noise means that becomes more possible. I think the stage after that, though, is some things that require human check. What's a good example? It's a obscure one, but on a regular basis, we have infrastructure that sort of doesn't match. You have a name and it's like 3 is the word and 3 is the number. And to a human, instantly, you'd look at those two things and go, oh, it's the same bridge, it's not an issue. But to the computer, it's bridge 3 and bridge THREE, and they're like, does not compute. So these are the kinds of challenges historically have been extremely difficult for computers to solve, because you need to give all the rules, and the rules for English language are very complicated. But if you do a report and it looks wrong, or it looks like you spelt something wrong, another engineer or the human being in an instant can spot that. The next stage of intelligent software is where, and I kind of mentioned it a little bit with things like ChatGPT, is where language challenges that have historically been the bastion of only human beings start to be possible within software. So you could scan something and go, these look similar, this looks close enough, or like this thing contradicts this thing. You said you were talking about York here, then suddenly you're talking about Bristol, and I'm pretty sure they're not near each other. Have you pasted in the wrong project? So I think that's the direction it will go in. It's sort of hard to see in terms of small steps, but it will be smarter and smarter parts of the process. And the last piece where the human input will be essential is, with all this information, what recommendation am I making? That's where the track engineer, is obviously remains supreme.
That's where I think I was trying to go with the question, David, in that when we free up the track engineer by the analysis of the data to look at the design again. So when we do the design again, we've got then the chance to bring the human brilliance to it and say, yeah, okay, that's okay. I've got the analysis of that, but I'm fine with that. I can then move the track this way or that way to improve the design and bring more of the designer to the problem rather than the analysis of data to the problem.
Exactly. Yeah. The calculation, the should ideally be kind of behind the scenes. You want as much output as possible, and it should be able to quickly explore lots of avenues and suggest things, even if you haven't been really explicit on what you're after. You can say somewhere around here and go, well, you could try this. This isn't possible, but there's some potential room here. And that helps, that elevates the user.
That's it. And that's that optioneering. Like, you've reached this point. Here's 3 options that are available to you at this point. You, as the human, would decide which is the most viable of those 3 options.
Yeah, I think optioning, that's a great way of putting it. Yeah, absolutely.
That's where I think the computing power and the analysis will go in the future. I think, I hope.
I'd love for that to be true too.
Okay, another point there, having everything in one brain sounds perfect, but data sets have a value. Do you see a freeware future for common data sets, or will data and analysis always come with a price tag that's determined and demanded by the data provider?
Yeah, it's a good question. I think it ties closely into this sort of historical model of localized data to the future model where it's centralized. When tools aren't forthcoming, the data set becomes valuable. Ultimately, if you've got the SQL database that no one else has got, you can leverage it. And unfortunately, a lot of people who sit on data probably it would be in their interest to open it up more because they could license it out for more things. Simply hoarding it is probably not the smartest commercial sense. I would say that once data is already online, once it's already been used by some users for some purposes, it's very little extra marginal cost to be able to open up to more people. It's in the interest of the data owner to be able to give it to a broad audience. Data sets like timetabling and compatible routes and sizes of certain tools and equipment. It's very expensive and time consuming to chase that, and usually have to go direct to OEMs, and it's again this manual process. But it's all there. It's all under the stairs somewhere in a server. So this is one of the things that as soon as it's centralized, everything suddenly becomes unlocked. So there's so much you can give away. There's value in getting people on platforms to go and find things and go, well, what else is here? And I can connect this thing with this thing. So once you open it up, it becomes a marketplace. So I see a lot of this being on every level. There's a lot of open source data for the railways, and it's enthusiasts that are compiling some of it and just sticking it up online just because. But bringing it together, I mean, there's huge opportunity to make it commercial, and without any few people sort of trying to hoard it all. I think there'll be a lot of free data.
I posed the question to try and tease out the business aspects of data, Dave, just to see where, obviously, DGH are a company, they're interested in making, increasing their profits, increasing their standing in the industry. And it's where that commercial aspect goes from enthusiasts who gather data, publish it online, and they don't care who uses it, to having reliable data sets that are gathered diligently by survey, which costs money, especially with access to the railway, and how that's then sold on. So I would think there was a market or an opportunity for the asset owner to fund his own survey and then make that survey available to the end users, the designers, and whoever would need to have maybe commercial people who want to run different vehicles, to be able to analyse routes and opportunities to say, I can move W9 containers from Immingham to Carlisle, if that was in my business plan, without having to get involved in a gauging exercise per se.
Yeah, I mean, a survey marketplace is a great example of that. I think it's something you can quite easily imagine. A lot of data surveys are held locally in companies, they're not centralized. There's a lot of duplicated effort. I mean, from a surveying perspective, there's obviously a business in going out multiple times, but ultimately having something available that you already have to the widest possible market is the easiest way to be able to, ensure revenue. And I think when it comes to route opportunity, and I touched on that a few times, I think, in the presentation, that it unlocks so much more. And if you have the vehicle, you have the survey data, these things are forthcoming without you having to really commission anything.
Indeed, and accurate as-built survey would be a bonus for that.
So just done a bit of work on our camera there. We've finally sussed out how to unblur it. And
I can see. It's nice to see it's not just Tom.
Well, there's other people here.
Yeah,
I'm just the mouthpiece.
That's great.
Okay, another comment there. If everything is stored on the cloud in the future, are we in danger of being held to ransom by dark forces? And if yes, how can we provide access to those that need it and prevent access for those that don't?
Yeah, I think I've worked on some of the first cloud products where businesses were skeptical, because the idea of, fallacy number 2, which is it must be in-house, otherwise I've not got control. It's quite an emotional response to something, because historically, if it's in my walls, I've got control of it. Now, the issue with, I haven't got the stats to hand, but what I can tell you is more companies lose data because of their own servers and their own IT and their own lost pen drives and their own lost laptops than get lost through Amazon Web Services and Microsoft Azure. Statistically, the safest place you can put your data is anywhere but your own building. Now, it's a generational thing. Again, if you grow up as the iPhone generation where all your data is already in the cloud, you don't want a whole bunch of CDs in your office. You don't want a hard disk that you could drop or catch fire or burn. So in terms of stats, it's very, very clear. But there is a piece in terms of confidence, especially when it's high-profile media hacks and things like that. Part of that Industry 4.0, one of the major parts of that was cybersecurity. So you can't have all these connections without security that keeps pace with it. But if the licensing model and the access model, even though when you draw a diagram, it's all in one place, the reality behind the scenes is many servers, many authentication, massive security, massive checks, and a log and a history of everything that's happened. So hacks will always happen. There's always going to be things like that. But if you embrace the latest technology, statistically, it's much less likely to happen. And this isn't the financial industry. We're not talking about bank accounts and those pounds. We're talking about, realistically, a survey of a bridge or, a project's going on. So that in terms of tier of data, it's not super, super, super high. And just like any piece of software with secure logins and decent IT policy, the safest place to put your data would be online, not under the stairs.
Good to hear.
I'm just going to jump back first before the last comment from Tom there. I missed one from Jonathan Lowe. Competence in data processing is an issue. Does DGauge centralise this and effectively remove the issue?
Okay, so data competence, data processing competence, that's quite a broad topic. I mean, certainly, I can only talk about the talented consultancy team that we have that obviously has their own checks and balances to make sure the right things are going out. I would say probably that the best example of that recently would be on the survey data side of things. So the RGDS contract essentially meant that the NGD is no longer provided by BT, is provided by Cordell. their data pipeline involves quite a bit of AI and automated collection and processing, but we worked or continue to work very closely with them on a lot of the QA checks. Thanks, Mark. And by that, we know that there's a fair amount of survey data in the NGD that isn't great. There's some speeds and curve radiuses and counts that seem kind of wacky, and they've been in there for a long time. DH essentially have a quality service that applies for all surveys before it gets published. So it's kind of a pre-flighting check, and it's automated. Obviously, we work very closely with our engineering team to define some of these, and there's warnings and blockers and sort of, you know, like a traffic light system in terms of data. And that's what Network Rail's asset information team to use to be able to approve this data. So that's kind of where, as an organization, we've helped data processing and automate some of these things. It's not a person who's checking them one by one, even the most diligent person in the world has no interest in checking 40,000 surveys every month. But we've turned that into software with my team. So that's now plugged into it. It's basically impossible for surveys on the NGD to be published without having gone through these checks. The Network Rails team have the ability to approve it and go, it's okay, I know that's tight, but it's a siding or it's some depot, we're okay with it. But it means that something that shouldn't be possible gets flagged up. So I think that's where technology can quite quickly plug into existing processes to help improve that processing competence. I hope that answers the question. That's the best example I could think of.
Yeah, sounds good. I think Jonathan's had to dial out, but hopefully that answers his question. Yeah. I think the last one we've got in the chat there is, as build data requires truth, how can the contractual issues be divorced from what has been installed? Would a safety amnesty work rather than the construction tolerances?
That's maybe a bit unfair. Sorry about that, Dave. It's about honesty in as-built. I think we rely on as-built data, or we will rely more in the future on as-built data being correct post-Carmen, and not just somebody simply scribing as constructed in a red pen on a PDF drawing.
Yeah.
That electronic as-built, including updates to the NGD, must be reliable, truthful, honest, and away from the contractual, oh, hang on a minute, you haven't built it within construction tolerances, and go to a safety review rather than a construction tolerance review and say, yes, okay, it's maybe not within construction tolerances, but is it safe?
Yeah, I take the point on that, and certainly there've been kind of discussions around construction tolerances recently that we're looking into the software. In fact, we've just added some. I think there's several ways to kind of approach this. I mean, you're right that there's the literal definition of what it should be, and then there's the practical real world one. And I think there's a similar kind of conversation between like absolute gauging and probabilistic. I would say that there's all kinds of ambiguity in certain areas that are accounted for, or there's enough fat in other areas that it sort of comes out in the wash. And I think a lot of those sort of that uncertainty kind of gets swept under the phrase like history of safe running, which is, well, it might be surveyed wrong and the tolerance is probably nonsense, but it's been there, you know, for X years and nothing's hit anything, so it's probably okay. And it's that it's hard to define exactly, but everyone kind of knows these things. I would say that as software and data starts to be more specific, you can increase the frequency and volume of surveying. You know, with probabilistic, you can be much more realistic in terms of the reality of the scenario. What you find is you'll lose in a few columns, and there'll be a lot of historical things that have been hiding that were okay, but now you're shining a brighter spotlight on them. They move into other columns. Something that was getting swept into one tolerance actually was another tolerance. It's diminishing returns. Because you can kind of over model things. There's a risk of that, but I would certainly say that I place a lot of value on as-built surveys and their tolerance, because ultimately that's the thing you're working from.
Okay. Any further questions? Anyone online want to come off mute and ask a question, or anyone in the room get any further questions? Okay, I'll jump to Satish. Just get in there first, I think. You put your hand up. On you go, Satish.
Please.
Yeah, hi David. It was a good presentation. Thanks for the presentation. Myself, Satish, working with Arcadis. I'm trying to understand how the D gauge is going to transition, and I'm trying to see if my wishes could come true one day. So, see, we have proposed some of the improvisations for the D gauge Rift as a company. We had formed a working group, and we have given some suggestions to Robin Mitten, and he has come back with some of his answers as well. But something we haven't included was two things I'm particularly interested. So the first thing is about the vehicles. So nowadays we are not, we have progressed obviously from the vehicle authorization and stuff like that, but we don't necessarily use now the vehicle authorization process. But then if I say my project is in this ELR from this mileage to this mileage, surely DGAGE should be taking all the vehicle list from network rail database, but still we are manually have to select all the vehicles, and there are chances that we are missing some vehicles, and some of the aspirational vehicles we don't consider, and we get a request from network rail to include other vehicles as well. So this should automatically happen. Would you agree? That there is a document with network rail H laws, which is having all the vehicle list in a particular ELR. So that should happen automatically, but that is not happening at the moment. So is this something in your cards?
Yeah, so I guess a vehicle compatibility. So I guess the input data sets and cloud data sets is kind of, I guess, a theme this evening. One of those data sets we integrate with as a product is NESA, is Network Rail's sectional appendix.
Yeah.
So we know every vehicle according to Network Rail that runs on every ELR. Now, the granularity that we suggest, and in fact in the software we suggest Network Rail compatible vehicles. So rather than having to select them explicitly, we suggest the ones that according to Network Rail run on that line. Now, the granularity of that list is only to line, to ELR. What we don't do at the moment is filter it to specific mileage. So if you're working on the start of MLN1 near London somewhere, all the vehicles that run there will be suggested, but actually everything right at the end of MLN1 near Cornwall will also be suggested, which is probably far too many. One of the changes we do have on our continuous improvement roadmap list is for narrowing down that data set. This comes into system I'm afraid I'll tie everything back to the big software piece this evening. The systems integration piece, which is here's a data set, how can we connect even better? And the way to do that is to look at mileage as well. So I think if we were to do that, that sounds like it would do what you're looking for, which is to have an even more targeted list of vehicles.
That's great. No worries. See, the other thing I'm kind of interested is once we have the gauging survey input into D-gauge, we should be able to dynamically change the vehicle so that we know what is the lift and slew required for certain clearances we are looking for. But at the moment it is not happening. It is a sort of linear process, so it's like a hit and miss. So we do a track design, we input that into the gauging, we find out that is not the clearance what I'm looking for. So I have to go back to the design software, change the design, but I don't know how much have to change. I just have to make a guess and then go back to D-gauge again. But then if I can probably adjust the vehicle dynamically within the D-gauge, in a way, do you agree that the clear route should tell me how much I have to slew to get certain clearances?
Yeah, I guess
not clear D-gauge, sorry.
Yeah, you have the option to sort of work backwards. I mean, we do provide the option The vehicle models, you've got different suspension cases. You can set it to obviously, a tear inflated and, narrow it down ACS or something like that to see if that wins you something. I think this ties into on the future slide I had with this idea of goal seek, where you can't just say, find me the clearance. That's too open-ended question. This is something that, again, that humans are too good at. But if you provide the right constraints, so for sake of example, if you knew that with a tamper you could happily move laterally 10, 15 mil or something like that, then you can say, within these boundaries, see if you can get me to normal, or see if you can get me 5 mil or 10 mil. That's a natural progression on top of the functionality we currently have. You can pick a survey in a vehicle and type in a lift and slew, but the process we try to make quick with, duplicate and then copy forward and then hit again. It's only probably 2 or 3 clicks, but you still have to, there's a bit of trial and error. So I would love to see, and in fact, I already have designs for, this is, I can't say if it's the next 12 months or so, but I would love to see it in the medium-term roadmap where you could give it constraints and go, just have a look around within this range and see if you can find me some clearance. Because then if you do, you're onto a winner and you can evolve it as a human. And if there's no chance, then it's a different level of intervention probably required.
Yeah, understand that. Yeah.
But the vehicle access one is easier than the goal seek one, but the second one's much cooler.
Right. Just thanks for that.
You're welcome. Thanks, Satish.
Tom,
my final point was about, I understand that gauging has a need for conservatism because of the nature of the work. And we have traditionally used various tolerances for different types of machinery used in surveys, platform gauges, laser point cloud machines. Do D-Gauge have an interest in trying to persuade Network Rail to adopt the latest tolerances that the latest survey machinery can give and stop the nonsense of having unknown survey data assign a 50mm bubble around about the point? Because that is so frustrating.
Yep. I did. I was working on survey tolerances this week. The old process, again, this comes back to the idea of local data sets, was when we imported the MGD, if we had a piece of equipment we hadn't heard about, we couldn't not import it and we couldn't guess. So the agreed behavior was default to 50, then pick up the phone, speak to Network Rail, ask them what it really is, and then we'll update it retrospectively. Now that's something that's necessary when you have the localized distributed data set. I mean, in my opinion, there's absolutely no reason why there could or shouldn't be a industry set of survey methods with associated tolerances, which could be a data set managed or even at least provided to Network Rail, which is publicly accessible. There's, it's a freeware thing. There's no point in charging for it. Anyone can access it. Anything connects to it. And then any survey that's done and submitted to Network Rail just picks one of those. Then there's never a need for, I don't know what this is, because there's a single source of truth and it's accessible to everybody. We, D-Gauge, have an equivalent of that. In the absence of an industry one, we have our own cloud database and it's a table of surveys. And all our tools connect to that. And anytime there's a new one, the second we hear from anyone that it exists, we update that. Like publishing that to the industry would be no effort at all. But it only works if we have this connected workflow where everyone subscribes to it. Whilst multiple people still maintain their own source of truth, you don't get to this ultimate kind of aligned situation. So I'm in massive favor of that. 50 mil is kind of silly. Or what we're focusing on at the moment is anything new. The turnaround to turn it into what it actually is, 5 mil or something, is quicker. But yeah, that should be a public domain data set, in my opinion.
Yes, in my view, it just stifled innovation. So you've got a brand new piece of non-contact laser survey equipment, plus or minus 2, and then number of parts per million. It means that basically, if you're very close to a platform, you can get it as near as 2 mil. And yet,
defaults to 50.
Or it's not going to be a platform, and a platform gauge at 11 mil tolerance. Come on. there isn't anybody on the line here or in the room here who could read a platform gauge at 2 mil. And yet 11 mil tolerance in a platform gauge. We need to get to the future. We need to get a bit more realistic about what we use for surveys and how accurate they can be.
Yeah, and I think that's the historical beliefs and behaviours of conservatives. And certainly, David Johnson has strong opinions on this and would campaign to all the right authorities on it. So I can't express too much opinion on it because I'm a software engineer relatively new to the industry, but certainly from my observation, there's an awful lot of things that are that way just because they have been, and we don't dare change them, even though all the data points that they should change.
Yeah, we've always done it that way. Eh?
Yeah. Thanks, Tom.
Thanks, Dave.
Okay, conscious of time a wee bit. Is there any last call for questions or comments from anyone at all? No. Okay, it just brings us to the vote of thanks, David. So I'll just do that and make a few observations as I go. Firstly, I was going to say major kudos for showing a ZX Spectrum on one of your first slides. So that took me back to Manic Miner when I was about 8, I think.
Absolutely.
It was a great description you gave us of how the gauging process has developed over the years, and from the introduction of the laser scanning and how gradually technology and cloud-based working has came in and taken us to where we are now. Also, some kudos on your style of presentation tonight. You took a very holistic view of cloud-based working, and you didn't push D-Gauge you didn't give us a sales pitch really, if you like, but it was good to get that insight as to a different, insight into how D-Gauge as a company are thinking about the future and technology and cloud-based working. So thanks for that. I picked up your point about the new generation being more IT literate and not being afraid to move industries to find something that suits. And I couldn't agree with you more on that. We've just started a 19-year-old apprentice last week, and it really does bring it home that it certainly made me more aware that I'm no longer a spring chicken anyway, and different styles of people in the younger generation. So
yeah.
Also your point about having all aspects of the IT system up to the same level, I think that's a great point. I think we're very guilty in the railway in the UK of having a massive amount of data collected, but not really the means to either store it or access it or work with it and manipulate it. We get cloud point scans, point cloud scans, etc., things like that. Great amount of information on them, but sometimes just very difficult to manage it. They're just so big files, and we don't have the technology maybe to manipulate it as good as we would like to. Again, picking up something Tom picked up on, interestingly, you're confident that AI won't replace people. I'm not quite so sure, because some of my team have tried ChatGPT to see if they could produce some reports. And it was pretty scary how convincing it was, actually. And now I don't trust anything they give me, and I've got to read it thoroughly and just check it for the AI underlines, if you like. And I was just going to say, Industry 4 sounds exciting, and when you looked at your list, it was interesting to see how much of that we've already reached. And you finished up with your vision of what the future might bring. I'm sure we'll look back on your predictions on our Apple glasses or a holograph projection very soon and compare where we are now. So I'll just finish up. I think thanks very much for a very interesting presentation, and try and do the virtual thanks thing, which isn't always that effective, but I'll ask everyone to join me in a round of applause with you anyway. So thanks very much, David.
Thank you.
Hope the camera picked that up good enough.
Appreciate it. Appreciate it. No, that's great. And I'll finish, I guess, by saying that I'd be more than happy to come back in 5 years, and you can test me on all the things I predicted, and I'll come up with a new set of things.
Glasgow's never an easy gig, remember.
Well, thank you very much. Appreciate it. And yeah, everyone, enjoy your evening. Thank you very much.
Thank you. Thank you. I think for those online, we'll just call it quits there and cancel the call. Thanks again, David.
Take care. Bye-bye.
Cheers, guys.